Hello everyone, in this video I'm going to be talking about how to use the technique of extraction to separate different compounds, and we're going to be specifically using the acid-base reactions to make sure how we can have one compound go from one layer to another layer, or another way of saying from an organic layer to an aqueous layer. So I'm going to take the example of these three compounds I have here. So we got benzoic acid, para-toluidine, and naphthalene. If we look at their characters and functional groups, the benzoic acid, since it's got the carboxylic acid group on here, so it's going to be an acid. For the second one is a base, and the third one is neither of them. It does not have any basic or acidic properties on it. So I'm going to just go ahead and call benzoic acid as an A, toluidine as in a B, and naphthalene as in a C. In terms of pKa's, the benzoic pKa is about 4.2. Toluidine's NH2, since it's an amine, it's going to be a little bit over 35, and we don't really have any pKa's for the naphthalene, or if we do, it's going to be very high. So we're just going to take that as a very neutral compound. Even though for A and B, we do have these the COH and the NH2. So they make this hydrophilic, but the rest of the molecule, and since it's relatively bigger, is hydrophobic. So as a result, these compounds, all three of them, are fairly water insoluble. None of those are going to dissolve in water. However, by playing with acid and base properties, we could make at least two of them dissolve in water. So that's what we're going to learn today, how we're going to be doing it. So let's start out with these three compounds. Suppose you have a mixture of those three and I'm trying to dissolve in water, none of those dissolve. So to make sure those dissolve, we can use um, acidic or basic aqueous layers, or acidic or basic water. The different types of solvents that you can use in this particular case could be the diethyl ether, ethyl acetate, and hexanes. Hexanes is going to be less likely to be used because they may not dissolve in hexane, but it's very likely they would dissolve in diethyl ether and ethyl acetate, and including in addition to that, we can also use dichloromethane or methylene chloride and chloroform. They should also dissolve in those too. The difference really going to be is the first three are less dense than water, so we're going to have the hexane, diethyl ether, and ethyl acetate. They're going to be on the top. They're going to be the top layer, and the water in that case is going to be the bottom layer. But when I'm talking about methylene chloride and chloroform, they are more dense, so they are actually going to be in the bottom. Um, and in that case the water is going to be the top there. So it really depends on what particular organic solvent you're using to dissolve those, and based on that you have to be really specific. Is your organic layer going to be on the top or is going to be on the bottom? So that really is density specific. Aqueous layer, as far as go, we can use plain water, or in addition to that, we could have an acidic or basic water. So for create an acidic or basic water, obviously we could use aqueous NaOH. And when we use NaOH, we could have anywhere between 1 to 3 molar NaOH. And for the acidic one, we can have anywhere between 1 to 3 molar HCl. That just creates the acidic and basic properties in there. And as far as the drying agents, we could use sodium sulfate and magnesium sulfate. They would be used to dry up the organic layer once we have extracted the compounds. So before we actually go use the organic compounds, I want to see what kind of reactions they would be doing under acidic and basic conditions. So if we start out with a benzoic acid, and since benzoic acid is actually indeed an acid, it would have the potential to react with a base. So it's not going to react with water, it's going to be water insoluble. But if I go ahead and use base, and in this case, we're going to be using an aqueous solution of NaOH, or we can just use the pellets of NaOH. Like you can have just the water and you can add some solid NaOH, and that would make that particular water solution basic. So this actually end up using making water here as one of your products, and then your second product is going to be the benzoate. So I'm just going to go ahead and take that away. And you're going to have a minus sign on here. So if I had called this A here, then I'm going to call this conjugate base as an A minus so that I'm not going to be writing or drawing the structure over and over. So just keep that in mind. If I want to look at where the equilibrium is going to be shifted in this particular case, this one is an acid that's in a base. So this is going to be your conjugate acid. Oh, that's going to be your conjugate base rather. And this is going to be your conjugate acid here. So if I'm looking at the pKa's, this is roughly 4.2 for the benzoic acid, and for water is about roughly 15.7 or almost 16. So there is a really good difference between the pKa's. So this actually will shift the equilibrium all the way to the right, or another way of saying you will have most of this compound onto the right side, or most of this benzoic acid has been converted into the benzoate or its conjugate base. Now, initially, when you had the benzoic acid, it was uh, insoluble in water, but then all of a sudden, when you make this reaction happen and you create this benzoate or conjugate base here, this makes this water soluble. So that's why you can use these acid-base properties to make sure we can have these compounds shifted from the organic layer to the aqueous layer. Okay, just like we have the benzoic acid, we can do something similar with the toluidine. So for the toluidine, I can just go ahead and now this isn't a base to begin with, so I want to go ahead and use an acidic water here, so you maybe an aqueous HCl there. And when I go ahead and do this reaction, let's see what it's going to make. The NH2 is going to get protonated, and you would end up having another hydrogen on here. So instead of having two hydrogens, I would have actually three hydrogens with a positive charge on here, and your Cl minus is going to be your conjugate base there. So when I'm looking at what's the base in the acid here, obviously this is going to be the base, this is the acid, that's going to be the conjugate acid, and this is going to be the conjugate base. Okay, so if you look at the pKa's, the HCl is a very strong acid. It has a negative pKa, and the ammonium salt here, or an ammonium ion here, is going to have a pKa of somewhere around 9 to 10. So as a result, this will be shifted completely to the right side, and we would have made this ammonium salt here. So I'm going to be calling this as an B plus, just as a reference, because I called this compound originally as an B. So once it gets protonated, it's going to be B plus. Now, this originally was water insoluble, but as soon as this has been protonated, as once it gets a charge on it, it makes this soluble in water. So you can actually make these compounds go be dissolved in the water by playing with their acid-base properties. So just like, if we go back and look at this first one here, once you have this benzoate here, that would be water soluble. But if I go back and add some more acid in there, like, just as a side note here, so just to get on a side note here, if I go ahead and treat this with an acid again, so if I add this acid, what's going to happen? It will go back to the benzoic acid. So I'm going to end up getting this benzoic acid back. And this benzoic acid now is actually going to be water insoluble again. So these compounds can go in and out of the water by playing with the acids and bases. So that's something you want to make sure you really know for these organic labs and also for the lectures. The third one, the naphthalene, doesn't really have any water solubility properties. It's just going to stay undissolved in water. So one of the best ways to retrieve this naphthalene from the water is by just filtration or maybe use an organic layer. So typically the extraction is going to be done by using two liquids. So you're going to have an organic layer and an aqueous layer. So I already talked about what kind of acid-base reactions you're going to be running. But now let's talk about if we have a mixture of those three dissolved in one of the organic solvents. I'll just go ahead and pick dichloromethane as my solvent here. You could have a different solvents. You could be using diethyl ether or ethyl acetate, but I'm going to be using methylene chloride, or you could also be using chloroform. So remember, the methylene chloride, also called dichloromethane, is actually more dense than water, so it's always going to be on the bottom, and your water is going to be on the top. If you had used diethyl ether or ethyl acetate or even hexane, they would be less dense than water, so they would be on the top and the water would be on the bottom. So that's something you got to be really, really careful with and be on the lookout for their densities when you're picking up the organic solvents compared to the density of water, which is just 1. And you will be using these drying agents, these acidic and basic aqueous solutions like NaOH or HCl. You may very well be using the concentrated HCl and NaOH just to kind of play with these acids and bases. So if you have just regular water, you may want to turn them into acidic or basic by using those acid and base. So suppose I go ahead and use those three compounds, and you could have very different ratios in terms of their masses. So you could have very well 1 grams of each mixed up already, or maybe, different grams of each mixed up, and they would be given to you, and you want to first go ahead and dissolve that in an organic solvent. And like I said here, I used methylene chloride, and I'm going to assume here they would dissolve. All those three would dissolve in methylene chloride. And if obviously you do want to test that if they would dissolve in a choice of given solvent here. But for right now, I'm going to assume they all do dissolve in dichloromethane. So once they have been dissolved in dichloromethane, so let's say, uh, if I want to go ahead and just have, so suppose this is the beaker I'm starting out with. All right, so I had a mixture that has been added in there. So mixtures of A, B, and C. Um, that's a solid mixture. They're all going to be colorless. That's added in there, and along with that, you have dichloromethane added in there. So suppose they all are dissolved in there, so you don't really see any solid. So if you have big chunks of those solids, you may want to just kind of make them fine powder and until they dissolve. So once everything is dissolved, I want to go ahead and transfer that into this SAP funnel. So I want to go ahead and have this methylene chloride transferred onto this SAP funnel here. So suppose this is your dichloromethane that has been transferred onto here. And then, first of all, I want to go ahead and add aqueous NaOH to it. So the aqueous NaOH also has been added to it, and you want to make sure you shake it really well. And I'm going to go ahead and change the color here. So NaOH is actually going to be base, so I'm going to go ahead and use a green color here. In terms of how much you really want to use, I would try to keep it like 1-to-1 ratio. So if I had originally 20 milliliters of this dichloromethane, I want to go ahead and use 20 milliliters of NaOH so that it's kind of even. It really depends on how much of the compound you're really using. You may very well be using 5 milliliters or 10 milliliters, so just something you want to keep in mind. You want to mix it really well. Once everything is mixed up, you're going to have obviously this top layer is going to be your aqueous layer, and the bottom layer is going to be the DCM layer or the organic layer. I can't really show those mixed up, but make sure you close the tab or close the lid of this SEF funnel. Make sure you give them little shakes or release the pressure, and you want to let this settle down. And once this has been settled down, you would have in the aqueous layer and you would have the organic layer. So now think about what you're going to have in the aqueous layer and what are you really going to have in the dichloromethane or the organic layer. So since we have treated this first extraction with a base, and if I go back here, the base would actually react with this benzoic acid and make this benzoate. All right, it would not react with the toluidine because that's already in a base to begin with. So I'm expecting this benzoate to be made when I have added this NaOH solution in there. So that aqueous layer should contain the benzoate, which is going to be the conjugate base of A. So I'm going to call that A minus is going to be right here. And your organic layer should contain the B and it should contain the C. So that's how you're going to be separating those. Now, I want to go ahead and have another beaker, so I want to go ahead and drain these organic layer and aqueous layer separated. So I want to go ahead and, let's say, write that down here. So I want to drain that into a beaker. So I'm just going to go ahead and use um, this picture of the beaker here. And now I'm going to have the organic layer that's going to contain the B and it's going to contain the C. So I'm going to go ahead and have the aqueous layer drained into a separate beaker. Is going to be your aqueous layer, and that is going to be fairly basic, obviously, because, and that's why I'm showing that with the green color here, and that's going to contain the conjugate base of benzoic acid, so that's going to be the A minus, and there, that's going to be dissolved in that aqueous layer. The B and C wouldn't dissolve in the aqueous layer, so they would stay in the organic layer rather. So you may want to run that again. So what that means, run that again. I want to go ahead and add, or you know, place that in the cephanol again, because you a lot of time you want to run these extractions at least twice. So I'm just going to go ahead and copy this down here. So I want to run this again, second time, because you may have a little bit of benzoic acid kind of gets still in the organic layer, so you want to run that again with an aqueous NaOH to make sure that you get every chunk of this benzoate into this solution here. I want to go ahead and add another 20 milliliters of NaOH. So remember, I'm not using the same NaOH that I have retrieved in this right beaker, but I'm using another set of 20 milliliters. And then I want to go ahead and mix those well, shake them, release the pressure and whatnot, and let those separate out. And then I'll retrieve this into the beaker. So that's just literally going to be the same thing here. So I'll just copy that. Okay, so that's after the second extraction. So you're still going to have a B and C in there, and then the remaining the aqueous solution, I want to go ahead and put that into the same beaker. So that's something you want to keep in mind. We'll just go ahead and add to the same beaker, and you can very well number those beakers if you want. I can call this beaker 1 just to kind of make sure I'm keeping track of it, or maybe you want to label those so that you're not mixing them at the end of the day. So after two extractions, if you want to run the second, third time, that's fine as well. But by the second time, you have retrieved most of it already. So you got this benzoate. But now the question is, how would I really retrieve this in the form of benzoic acid? So remember, this isn't a benzoate that you got in this beaker 1. And right now it's water soluble because it's in the ion form. So what I can do now, right now it's in a basic solution. I can go ahead and add an acid to it. So I want to add concentrated HCl to it. So I want to add concentrated HCl slowly until this turns into an acidic solution. And how do I really know it has been turned into an acidic solution? Obviously, you want to use the litmus paper, and right now the litmus paper would be the green one. But as soon as you start adding the HCl, eventually once the pH goes below 7 and it becomes acidic, it's going to turn into a pink and a red. So that's something you want to use to check the pH of this particular solution. All right, so I'm going to go ahead and have this here, and I'll probably change the color here just to kind of gives you an idea that when you're checking with the litmus paper, that is going to turn pink to red. Okay, so right now, what's the reaction going to happen? So you had this benzoate in there. So I'm going to go ahead back and grab this benzoate that I got earlier. So this was benzoate in there, and once you have added the HCl in there, and once this becomes acidic enough, you would have converted this benzoate into the benzoic acid here. So now you would have the H there. Now this is actually going to be insoluble in water, and as a result, it would precipitate out. So this thing is going to precipitate out on the bottom here because it would be insoluble in water. So once it has been precipitated out in the water, you want to go ahead and filter this. So once you have filtered this and you're going to get your solid on the filter paper and want to go ahead and dry it, and that's going to be your crude. And eventually you want to go ahead and recrystallize. So I will make a different video on the recrystallization, but that's just the next step you would have to do once you have filtered this out. So you want to go ahead and recrystallize it, and that's just where you have your benzoic acid. So you want to make sure you go ahead and get the mass of the crude, and you want to go ahead and get the mass of the recrystallization for the calculation purposes at the end of the day. Okay, now coming back to the organic layer. So organic layer still contains two things, and we need to go ahead and get those separated out. So what I want to do now, I want to go ahead and add this again into Ceph funnel. Okay, so we'll just go ahead and have this added into the Ceph funnel. So make sure you kind of clean the Ceph funnel as you move. You can just clean it with water. And then I want to go ahead this time add the HCl solution because we've already done the extraction with the basic solution. Now we want to run with an aqueous HCl solution. And an aqueous HCl solution means you could have very well either 1 molar or 1 to 3 molar HCl. Any one of those should be fine. I want to go ahead and have that added in there. Now I want to go ahead and mix those, shake this really well, make sure you have the lid closed, release the pressure and whatnot, and then let this settle down. And once this has been settled down, what's going to happen? Now, this HCl, since it's an acid, is going to react with toluidine. So it's going to be now reacting with this toluidine and making this salt right here. Now that salt would be water soluble. It would not be soluble in the dichloromethane. So then right here in the aqueous layer, I would expect to have the conjugate acid of that toluidine. So I'm going to go ahead and write that down as in a B plus here. And then on the bottom here, I'm going to have still the naphthalene. So the C is still going to be in the organic layer. So then well, we're just going to have to repeat the process. So I'm going to go ahead and get the beaker and drain the bottom layer first. So once you have drained the bottom layer, that bottom layer would contain only the naphthalene now. And I want to go ahead and get this top layer or the aqueous layer into another beaker. So I can probably call that beaker B. I'm just going to erase this momentarily. So this would contain B plus on it. Okay, and you want to run that again. Always run the extractions twice, and make sure, obviously, when you're removing these solutions from the Ceph funnels, all you're really going to be using is this stop cocker right there to open this. So first you drain the organic layer, and then you drain the top layer, which is the water layer in this case, and then Whenever you're draining the liquids, one thing you always want to make sure you don't have any lid on the top. Otherwise, it's going to build in the vacuum and it's going to mess up the separation of these two layers. Always open up, take out the lid from the top, and that's when you start draining it. Okay, so I want to go ahead and run this again, and I'm going to go ahead and add second round of aqueous HCl. All right, so that's going to be another, if we have been using 20 milliliters, so that means another 20 milliliters. So just keep in mind whatever volume you pick to use. Um, and then obviously this is still going to have C, and then whatever amount of, if you had any toluene left in the organic layer, that will be washed into the um, aqueous layer for the second time. And I want to go ahead and have that in right here. So I want to go ahead and drain again this organic layer. Make sure you shake this really well, release the pressure, and eventually you want to go ahead and drain this by opening the knob on the bottom. So I'll have this drained into this C first, the organic layer. So that's going to contain compound C, which is the naphthalene. I want to go ahead and get this water layer or aqueous layer drained into this previous beaker that we were using. So now we're going to have a collective volume of maybe 40 milliliters. So this right now, if you think about it, it's the toluene conjugate acid. So it's a protonated toluene and it's water soluble. Now, how do I really retrieve it from here? So I can probably call this beaker 2 right here. And to retrieve it from here, what I really need to do is add base. So I want to go ahead and actually add concentrated NaOH because I don't really want to have too much water in there. So maybe add literally the pellets or solids NaOH, or maybe the concentrated NaOH that you have made. So once you have start adding the NaOH, right now the pH is going to start increasing and eventually it becomes basic. And once it turns basic, your toluene would not be protonated anymore. So I'm going to go ahead and change this color to green because by the time it's turned basic, you should have your toluene protonated, toluene precipitated here. So once your toluene precipitated, okay, so the toluene is precipitated here. I want to go ahead and filter it. All right, so filter it. On the filter rate, you're going to get this crude. Make sure you get the mass of the crude toluene. Make sure you get the mass of the crude, and then you want to go ahead and recrystallize it. Okay, so that's how you get this second compound here. And now we come back to this organic layer that we got in here, and we still have this third compound, which is the naphthalene. Now, naphthalene does not really show any acidic and basic properties, so as a result, it's still kind of hanging in this organic layer. So what do we do now? Like, you don't really have anything in there. So first of all, I want to go ahead and dry this out by adding the drying agent. Now, why do I really need to dry this out? Because even though you have extracted and the water was separated and your DCM was separated, there's still a good chance that you may have a little bit of water in this organic layer. And to kind of make sure that all that little bit of water is gone, you want to dry it up. So to dry those up, I want to add either sodium sulfate or magnesium sulfate. Any one of those is fine as my drying agent. So I want to add um, Na2SO4 slowly. So if you has a little bit of water in there, it will make the clumps of those Na2SO4 in there. And once all the water is dried up, those crystals of sodium sulfate would be freely moving in the solution. And that's when you really know that you have dried up your organic layer. This is a very crucial question, and a lot of times students get confused, like how much how much sodium sulfate I really need to add. So you start with a small one, shake it, And if it's making the clumps on the bottom, so that means the solution is still wet. So you want to keep adding the sodium sulfate. And at some point, once it has absorbed all the water from the organic layer, it would start moving freely in the form of crystals, and it's crystals, and you would see that very clearly. It's very hard to miss once the crystals are moving freely. Even if you add a little bit of extra, it's not really going to hurt you, all right? So you're going to have these crystals on the bottom. So I'll just say right there, these are your crystals of Na2SO4 moving freely. And then obviously you want to go ahead and get rid of those. And to get rid of those, I want to go ahead and filter it. You can probably just run in a gravity filtration here. You don't really have to run the vacuum filtration like we were doing previously. Once you filter it, I want to go ahead and get the filtrate into maybe a round bottom flask, maybe into another beaker. It doesn't really matter for right now. So this contains DCM, and so this organic layer right now is going to contain compound C, and obviously we can retrieve that compound C by evaporating the dichloromethane. Dichloromethane has a relatively low boiling point, so you can probably just do a couple of things. If you have a very small amount of dichloromethane, you can just kind of air dry it, or you can just put it on a hot plate. Remember, you can't really do this hot plate thing on with a lot of chemicals. Like you don't really want to put a diethyl ether on a hot plate because it can catch fire. But dichloromethane, it's fine. You can warm it up a little bit, air dry it so that it can evaporate. But this will work only if you have a small amount of dichloromethane. But if you have a large amount of dichloromethane, maybe you need to either perform the distillation. So distillation is another technique that organic chemists usually learn. So either perform distillation, or there's a tool called rotovap. You can use rotovap, which actually pulls out all the liquid, and it's going to leave your solid behind. So, you take out all the DCM. And to do the distillation, you would have to put this in a round bottom flask, and also the rotovap. So make sure right here you very well be using in a round bottom flask. If you just have a little bit of liquid and you're putting on a hot plate, then you can use maybe a a beaker. But if you're using distillation or rotovap, you would have to use a round bottom flask. That will take out your dichloromethane, and what's going to left behind is going to be your compound C. So compound C is going to be left behind, and obviously it's not really going to be pure because I kind of been through a lot of those things, so it may have some impurities in there, and to purify it you would have to actually recrystallize it. So maybe you want to go ahead and weigh this, because that's still going to be crude, and then you want to go ahead and recrystallize it by picking a solvent. And once you have recrystallized it, you can, at the end of the day, you can take the melting point, you can take the mass again, so to do that, all sort of calculations. So this is like an overall pictures of the extraction